Okay, moving along here, graphing piecewise functions. One strategy that you can do here, which is a perfectly fine strategy, and I've showed you this before, is graph both individually and then just erase the parts that you don't want based on the restriction of the domain. So notice that both of these here, these are both horizontal lines. So if we want to graph f of x is equal to -4, we'd end up with something right down there. We'll put those arrows in later once we figure out what side of that line we want to keep and which one we want to get rid of. Now we got to put in the 2. F of x is 2, which would be this right up here. Now let's put the break in the graph. This graph is broken right when x is 3. Right there. So what parts of the graph do we keep and what parts do we get rid of? Well, according to this, I want the -4 graph if I am less than 3. Which side of this blue line, this dashed line, is less than 3? It's the left side of the line. So I want that on the left side of the line, which means I don't want it on the right side of the line. So I'm going to erase it right up to that point. Now if I want the blue on the left side, that means I want the red on the right side. Notice we back that up by looking at this here. We want 2 when we are greater than or equal to 3. So we're going to erase this part here. Okay? Make this have a unified look right there. Now I need to give this some marks here. Oops. In terms of the open circles and the closed circles, right? Now we do that by looking at the inequalities. This line down here, I want that when we are less than 3. So less than 3, that gets the open circle treatment right there. And then up here, if that's open circle down there, then this must be filled in circle there, which we can see when it's equal to that 3. Okay, let's look at the other one. Another strategy you can have, notice I made both and then I erased. Another strategy that you could use on these problems is worry about the break in the graph first. The break in the graph occurs at 2. Oops, kind of missed it. Let's slide that over there a little bit. Not as easy as it looks. There we go. And so now if I am less than or equal to 2, I want this line right here. Less than or equal to 2, it's on the left side. So linear function, got to start at -1. Let's apply the slope of 2. 2, slope of 2, that's up 2, 1, 2 to the right 1. Repeat, up 2 to the right 1. Now what happens here that I got land this line? Because this is equal to there, I want a filled in circle right there. We can reverse the pattern if we want to, but we have enough. We can make our line. And it goes out in that direction. Now what happens if we are greater than 2? If we're greater than 2, then we are just simply at -5. So right here where we left off, right here at 2, we'll pick that up right down here at -5, an open circle, and then we'll continue this way. Realize we would have done the same thing over here. We could have used the strategy of graphing both and then erasing. This one here, it's all about the horizontal line test, right? So looking at this here is the relation to function, not about the horizontal line test. What we are looking at here is this relation. This one right here is as a function. You can see it fails the vertical line test a bunch of times here. So that's definitely a no. Is its inverse a function? Notice that when we use a horizontal line test on this relation, notice no matter where I put this horizontal line, I'm hitting the graph once. So this inverse of whatever it is we have here is going to be a function. Over here, this thing will pass its vertical line test. Okay, passes its vertical line test. Notice that if we turn this into make it a horizontal line test, oops, moved the wrong thing there, didn't I? That's better. Horizontal line test, I'm not hitting this at multiple spots, even right there. Kind of pixelated there, but yeah, we're not hitting that graph more than once. So that's a C for both. Yes and yes. Okay, now graphing a piecewise function, or writing the function if you're given a piecewise function. A couple things that you might want to notice here is note where that graph got broken. That graph was broken right there at -2. If we are less than -2 for that function, we're going to have 6. Now notice I said less than. The reason why I'm saying less than is because there's an open circle there. Now if I'm saying less than -2 here, what kind of leads is the next move here is now when you glance here and see the filled in circle with this line with some slope, notice that leads directly into us saying, well, if x is greater than or equal to -2. Now it comes time to figuring out this line. Like I said in class, I'm nervous about how you guys handle slope. Remember, make it go from the left dot to a right dot. And here we go down 4 and to the right 2, and we repeat that pattern. A much more efficient way of doing this is noticing that we can go down 2 and to the right 1 each time. We can still get there. So that slope's going to be -2. Put our x in there. Now y-intercept. Remember, don't make this number here wherever this starts at. That's a big mistake. Remember, we have to put that value as the y-intercept here. Notice that y-intercept is 0. So why even write this in here? You can just write it as just -2x.